Well, hello there, ladies and gentlemen. What we're going to be doing right now is we have this wonderful square root stuff that we did last week. We took a test. We're going to go over that right now, shall we? So the very first question said that if m squared equals 5k, what is the value of the square root of 5k? Well, to answer that question correctly, to get it like, look, I could just tell you the answer, but to understand how to get the answer, you have to understand what this really means. This right here, this is a number. This thing right here, the whole thing is a number, and it has a property that if you square it, you get the radicand. That's what square roots are. So if you have the square root of 4, the reason that it's equal to 2 is because what this number means is that if you square this number, the product is the radicand. Well, that is true of 2 squared is equal. Oh, sorry. Sorry, I was thinking 2. So let me start that over again. Hold on. Let's back the truck up right here. All right, so square root of 4, what that means is this is just a number, and it's a number with a property. This number, if I square it, the product is the radicand. So the square root of 4 squared is 4. That's the property. That's why the square root of 4 equals 2, because 2 squared is also equal to 4. So, it's that whole thing. It's a transitive property. If A equals B and if B equals C, then A equals C. So if A equals B and B equals C, then A equals C. That's it, right? So that's what this is really getting at. If you understand this, then you should be able to understand what this is. So this says this is a number squared that equals 5k, right? So it's m, right? So the square root of 5k is equal to m. And the reason why is because this number right here, if you square it, you get 5k, right? And m, if you square it, you get 5k. So that means these two things are equal to each other. Yep. All right. Man, I think it's coffee time. I can't quite, I don't know. Let's see if I can do it without spilling. Oh, you can watch the whole disaster. Look at it. Can you see what the side says right there? Oh, no, it's almost going to spill. Nerds rule. Man, fancy that. Okay, nerds get jobs, right? All right, so next up, buttercup. It says, what's the most accurate way to write the number squared that equals 27? So the number squared that equals 27, the most accurate way to write that is actually going to be 3 times the square root of 3. I guess you could say this would be it, but that can be simplified. This number squared equals 27, for sure. This number squared equals 27, and this number squared equals 27. That's it. The most accurate way is not with a decimal, so 5.196 whatever. That's an approximation because this decimal expansion, it doesn't have a pattern and it doesn't stop. So anytime you approximate, it's just close, it's not exact. So if we're going to be talking about the most accurate way, we're going to keep using these radical symbols right here. All right, next up, it says to simplify the square root of 7. Well, that's already simplified. That's it. Can't be done. You could rewrite it as an irrational number. You could rewrite it as a decimal approximation. It's 2.6 something. I don't really know, but that's not simplified. That's approximating. So simplified is already there. All right. Simplifying the square root of 16. The square root of 16 simplified is 4, right? And let's see here. Next up, square root of 18. Well, since 18 is 9 times 2, the square root of 18 is the square root of 9 times the square root of 2. This says, hey, this number squared is equal to 9. Is there another number squared that equals 9? Yeah, 3. There we go. So the square root of 18 is equal to 3 times the square root of 2. And the reason that's true is because you can square it and you get 9 times 2, which is 18. All right. Next one says to simplify the square root of 9 root 2. That's already simplified. The reason this question's there is because a lot of people say, oh, look, there's a perfect square, so 9 equals 3. 9 does not equal 3. 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 is 1, 2, 3. Those are not the same. In no way, shape, or form are those two things the same ever. Now, however, the square root of 9 does equal 3, but the square root of 9 is not this. This is like, you can consider it this way. It's like a square, right? Squares have all equal sides, all right angles, right? With an area of 9, and it's saying how long is the side. That's the square root of 9, okay? All right, square root of 162. Running out of room right here. Square root of 162. So these problems are written to be simplified. There's going to be a factor of this that's a perfect square. What you're going to do is you're going to factor the radicand, which is 162, is called the radicand, and you're going to find the largest perfect square. Well, 81 times 2 is 162. The square root of 81 is 9. 9 root 2, boom, done. And that cannot be simplified anymore. All right, what about the square root of 25x cubed? Well, the radicand is 25x cubed. We need to factor that and find the largest square number. Well, 25 is a square number. X squared is a square times x. That's what it would be. The square root of 25 is 5. The square root of x squared is x. Boom, done. And that's true. This and this are equal. Those two things are equal. And the reason they're equal is because if you square this, you're going to get 25x cubed, right? You got 5 times 5, that's 25. You got x times x, that's x squared. The square root of x squared is x, and x squared times x is x cubed. Do you see? That's why this right here is the same as 25, the square root of 25x cubed. All right, onward and upward. Next things, here we go. Oh man, we got some addition and all kinds of stuff going on here. We got the square root of 45. Let's see here. Square root of 45 and then plus the square root of 125 x to the power of 2. All right. Well, 9 times 5 is 45, right? 9 times 5. So square root of 9 is 3. 25 times 5 is 125, right? 25 times 5 is 125. And the square root of x squared is x. So there we go. So here, we can't actually add these. These are not like terms. If this x wasn't here, then this would be 8 times the square root of 5. But, yeah. All right, now, I didn't show you the work for this, but look, 9 times 5 is 45, right? Take the square root. That's where the 3 comes from. This is 25 times 5 times x squared. The square root of 25 is 5. Square root of x squared is x. Do you see how the 5 is left and the square root of 5 is left? That's all you can do right there. Done. Not like terms. Okay, next up, Buttercup says 2 times the square root of 18 plus the square root of 8 minus 3 times the square root of 72. Okay, this one we already have done, so this is going to be 3 root 2, right? That's what the square root of 18 equals, but 3 root 2 times 2 is 6 root 2. Do you see? See, look. 2 times the square root of 18. That's the same as this. It's the same as 2 times the square root of 9 times the square root of 2. That's 2 times 3 times the square root of 2. That's 6 times the square root of 2. All right. Plus 2 root 2. And then 36 times 2 is 72. The square root of 36 is 6. You see? 6 times 3 is 18. So this is going to be negative 10 times the square root of 2. Just combine like terms. That's 8 minus 18 is negative 10. Okay, next up, Buttercup. Here's what we got. We've got parentheses, 3 root 4 minus 2 root 9 squared. Order of operations, PEMDAS, can really save you a lot of headaches. Look, simplify this first. Anything in a group you want to do before you can do an exponent, right? Square root of 4 is 2, right? 2 times 3, 6. Square root of 3 is 9, or square root of 9 is 3. 3 times, ooh, well, that's 0. 0 squared is 0. Done. All right, fancy that. Okay, now the one that, man, math teachers do this on purpose to make fun of you. I promise. The square root of 400. Well, doesn't 100 go into 400? Like, even if you can't think of anything better, look, isn't 100 times 4 400? And those are squares. This is 20. See, look, that's 10 and that's 2. When you take the square root of 100, that's 10. Take the square root of 4, that's 2. That's 20. 20 times 20 is 400. Dang. All right. Next up, the square root of xy squared. Well, we don't know what x is. We don't know if it's a perfect square or not. We don't know what y is, but it is y squared. So the square root of y squared is y. See, look, the square root of y squared, it's saying, hey, well, here's the deal. Look, if you square that number, it's y. It's saying, hey, what squared is y squared? Isn't y? What squared is y squared? What squared? What squared is y squared? Well, that's just y. All right, so the square root of y squared, y. All right. Next up, buttercup. Let's see here. Man, let's see. So square root of 5. Square root of 5 times square root of 45 plus the square root of 20. Now, we could distribute first, but I still think it's better to simplify first. All right, so check this out. This is 9 times 5. Square root of 9 is 3. This is 4 times 5. Square root of 4 is 2. Those are like terms. Oops. That's supposed to be parentheses. Oh, now it looks like your picture in the yearbook. All right, sorry about that. 5 root 5. A lot of 5s there, right? Now we're going to distribute. So look, this is 5 times the square root of 25, right? The whole thing equals 25 because this is 5. Yeah. Now people get confused, like when they're multiplying three numbers together, like 3 times, let's say 2 times 3 times 4. Everybody knows that that would be 24. But when they put it in parentheses, they're like, oh, don't you have to distribute? No, that's not it. If it was a plus, then yes. But with multiplication, like here, this is all multiplying. No, you don't. It's just multiplying. That's all. Okay, almost done. Couple more left. 3 over the square root of 3. So this is an irrational denominator. We have to fix that. We're going to rationalize the denominator. This number equals 1. When you multiply a number by 1, right, something divided by itself is 1. When you multiply by 1, it doesn't change the value. So here's what we got on the top, 3 root 3. On the bottom, square root of 3 times the square root of 3 is 3. That can be reduced to just square root 3. All right. How about this right here? 5 divided by the square root of 2 plus 2 divided by the square root of 5. I know a lot of people had questions about this one. Oh, man. So to do this, we're going to have to get a common denominator. And we could do it now, or we could do it later. Doesn't really matter. By later, I mean what we could do instead, we could rationalize these denominators first and then get a common denominator. It doesn't really matter how you go about it. My inclination is to get a common denominator now. So that's going to be the square root of 10. Yeah. So the way I get this to be a square root of 10 is I multiply by the square root of 5 over the square root of 5, right? That gives me the square root of 10, right? And that's 5 root 5. Okay, now this one I have to multiply by root 2 over root 2, right? Plus 2 root 2. Yeah, okay. Not quite done because, let's see. We have to multiply by square root of 10 over square root of 10. And here we have to make sure to distribute. We have to multiply it by everything inside that parentheses. So, square root of 10 times square root of 10, and the denominators is just 10, right? Let's look at this. Let's look at this right here. 5 root 5 times square root 10. Well, isn't that going to be square root of 50? That's the square root of 50, 5 root 50. But isn't 50 25 times 2? And 25, square root of 25 is 5. And 5 times 5 is 25. 25 times square root of 2. 25 square root 2. Okay. And then this one, 2 root 2 times root 10. Well, that's square root of 20. And that is, 20 is 4 times 5. So that's 2 root 5. So 4 root 5, because it's 2 root 5 times 2 is 4 root 5. Boom, done. Man, that is some hotness right there. Now, let's try that same one again. Well, for the sake of time, we won't. I'll do another video for just that problem. We'll do it 2 different ways. Almost done. Next up says square root of 8 divided by 2. Those cannot be reduced because this is a rational number, and that's irrational. But the square root of 8 can be simplified to 2 root 2. And then that can be reduced. Square root of 2. Now this one, for example, this is different. This can be reduced. That's the square root of 4. See, 2 goes into 8 4 times. Square root of 4 is 2. Almost done. Let's see. We got 2 problems left. We've got 5 square root of 3 divided by the square root of 15. Okay, we can reduce this. You should reduce before you rationalize the denominator. So that's going to be 5 over the square root of 5, right? Because, 3/15 is 1/5, right? Okay, and then rationalizing the denominator. Oh, running out of room over here. So that's 5 root 5 over 5. That's 5. These two make 5, right? 5 root 5. And then that can be reduced, and your answer is just square root of 5. Boom, done. All right. Last up. Last one. It says, so we've got this thing right here, right? That's a good old-fashioned right triangle. That's an x. This is a dos equis. This is a square root of 125. And the instructions say what do they say to do? Find the value of x. So we need to find the value of x. Because this is a right triangle, the Pythagorean theorem holds true. A squared plus b squared is c squared. That means if you make a square out of these sides and you add them up, the area will be the same as the square of that side. So x squared plus 4x squared equals 125. Reason that's true, plugging everything in, right? If we wrote it out, this is what you'd get. That's x squared. That's 4x squared. That's 125. So that's 5x squared equals 125. So x squared equals 25. So x equals 5. Boom, done. Now, it's true that the square root of 25, the square root of 25 has 2 answers. It's 5 or negative 5. But in this case, the negative 5 doesn't count because distance, this is a distance is always positive. So there we go. Anyway, hope this has been helpful. That was the whole quiz right there. Let me know if you guys have trouble. I hope you're having a great day. Be safe, and I'll talk to you soon.